Hey everyone, I keep on getting questions from YouTubers, students, and also technicians about my diagnostic strategies, procedures, and more people are requesting that as we're diagnosing a problem, I take step by step and kind of go through it. So here's an example of my diagnostic approach and procedures. It's a bit of a long video, so if you don't like it, just skip past it. But the big thing is that I always do is maintain voltage, battery voltage, have a maintainer on there, a jump box or something. And check all the codes in the vehicle, get a baseline of all the DTCs in the vehicle. I always like to take a reading of the grounds on the vehicle as the scan tool's doing its work. In this example, I definitely had a ground that I didn't like. I thought it was high, the voltage between the battery ground and the engine block. And it turned out that that was another problem that we ended up addressing as we went through the fix. All right, getting this thing fired up to take a look what's going on here. Complaint is something about a mass airflow sensor code, and the guys in the class here have already been chasing after stuff, as you can see. So we're gonna have to just get a baseline to start. I almost always start with making sure I got good battery voltage. Put a maintainer on there just because there's no point of checking stuff with a battery that's going dead and you just don't know. As you see, we got ourselves a Saturn, what is this, Aura temp tag. Couldn't pass E-check apparently. Go for automatic if it'll do it. Let's see if this thing will read the VIN. Note, I'm checking that we do have a check engine light. If you don't have a check engine light, you're going to have some sort of other problems going on in most vehicles. So, okay. And as the vehicle is IDing itself, the VIN number that comes up on the scan tool, you want to make sure that matches the vehicle. There's a good chance of having wrong calibrations if somebody put the used computer in there. So let's do an auto scan. Let's start out checking everything. Always like to get a good look at all the codes in the vehicle. And while that scanner's doing the auto scan, I like to get a look at the just do a couple basic tests that I do on almost all cars, because sometimes you spend a minute while the scan tool's doing this thing, you find a problem before you even get codes. Just gonna go and test my meter, make sure we got good voltage there. I'm testing the block. It's a little on the high side. So I'm going from the block, or the intake manifold here, the steel intake manifold, to battery negative. Showing 220 millivolts with P on. That's on the high side. So it looks like we got a little bit of a high resistance in the ground for sure. Or more of a voltage drop than I like on the ground side of this thing right off the bat. Let's go back and check our code. Okay, so I'm going to click the report button, and I'm just going to scroll down here. So we have a mass airflow sensor, circuit low voltage, ignition switch 2 circuit. Interesting. EBCM has a bunch of codes. Invalid serial data, that's going to set anytime you got like a mass airflow sensor map sensor problem. Most of these codes, besides this lost communication CAN bus problem, are going to be related to the engine DTC of the mass airflow sensor. Escape out of here. Let's just take a look at our engine. I could start this thing up and see how it runs too. Here, surgery sometimes. And while that's running, I'm going to take a look at our live data. And next step is going to be taking a look at the, I want to take a look, mass airflow sensors is 0. I don't like the autel because it always reads in pounds per second, which is just I don't like that, but I like to see grams per second. So I'm going to go take a look at where this mass airflow sensor gets its powers and grounds. It's already got a new one hung. Would you believe this? My computer's not turning on today. But I do know, based on my little bit of experience, always checking my meter before I get started here, the pink wire to the mass airflow sensor should be hot. I got to verify that before I go condemning anything. But let me just back probe this in here real quick. And 1.8 volts is never good if we're looking at a power, right? We should have battery voltage there if this is the correct circuit. So I got to find out where we're losing our voltage, where we have a voltage drop, and also verify that that's the proper circuit. Diagram 3 is what I wanted. So there is a fuse that powers up the pink and black wire of the mass airflow sensor. Guys, when you're looking at diagrams and you have a complete box around the item, that means you're seeing the entire, all the wires coming in and out of that item. In this sense, in this case, we're talking about the mass airflow sensor. So when you see the dotted line, that means there's other parts to that diagram or other parts of that component. So we have the complete picture of the mass airflow sensor. So we have a black and white should be our ground, G107. We have a pink and black, which is terminal B. That should be our power, and that comes from emissions fuse number 6, 10 amp. So we're going to go on a hunt here, see what we got underneath the fuse block. Fuse number 6, we have 13.6 on one side of it. Test the other side, we have 13.6. So that means that between this side of the fuse and here we have a voltage drop. So that could be internal to the fuse distribution center, or it could be in this line. So next thing I think that would be the easiest to do is pop this fuse block up. Let's back probe connector 1, terminal B11. Okay, as we're working here, just so you guys know, I've seen at least a dozen times in my career that these bolts will be loose because somebody did some job and didn't tighten them all the way, or I don't know what, but and the connector underneath the fuse panel will be very loose and cause all kinds of problems. My challenge here is getting this thing up, deciding whether I want to pop out the battery and use jumper cables to power the car so I can do some testing. But at this point I think I'm going to have to locate, figure out actually which connector it is for the circuit so I can decide which angle of attack. We're still at 1.9 volts at our mass airflow sensor. As I was wiggling over here, it went up to 2 volts at one point, but there's a problem somewhere. I'm pretty confident that we're going to have a voltage drop between the fuse block and the mass airflow sensor. If it's not there, it's going to be in the fuse block itself. So we'll take a look. So we're looking for B11. Let's make sure that that is mass airflow sensor. It's the same circuit, pink and black, ignition 1 voltage. So where is that at? So this is looking like with a connector unplugged. So we got A1, so B1's going to be in a corner above A1, right? And what's A1? A1's not used. Let's go to A2, should be a gray wire. So if we get the right circuit here, we'll know where to go. Alright, check that out. That's the view we want of this thing. So wherever the studs are on the one side and C1's opposite that, so I'm pretty confident. There's that. So this is C1 right here. I'm just trying to not disturb it too much to get it up in there and check. Okay, everyone, got that cover off. I got down to that connector. Something I don't like about this fuse block is somebody's been here so much, all these relays are like super loose. When you just touch them, they're falling out. I'm not happy about that, but you know how it goes. So I'll put the phone down there. I can't even see myself, but this is the wire we're going after. So I'm going to go down there and back probe that. So I'm going to leave my other lead here at the mass airflow sensor. So we're going to be on the same circuit here. the whole idea of a voltage drop test is to measure the voltage dropping in a circuit. It's not that hard, everyone. Let me go with my bookmarks here. Pull up that picture I had so I can just show you guys. Where did it go? Number 3. So we're going to be putting our voltmeter back probe here and the other lead there. And what we want to see is a very low voltage. If we have anything above like a tenth of a volt or more, there's a problem in that circuit. So I'm going to try to test that. Don't know if I can hold the phone and do all this at the same time, guys. Hats off to Keith out there. He's doing it all every day like this. I got more people asking me how I do stuff, and they want to see it live, I guess is the word for it. Alright, so couldn't hold the phone as I was doing it, but I have that lead back probed in that circuit. I'm over on the same circuit there, and we're reading 11.3 volts on the same piece of wire, guys. That's no good. We can tell somebody's been hunting around here. So I'll get this light out of the shadows. There's a couple of stripped back wires. So if I had to take my guess, I'd be assuming we're going to be in this mess down here is probably where the problem's going to be. Just going to try and take a look. Sounds like something's going to blow up outside here. Alright, so guys, I had to take out this little thing here. I've got my little miner's hat on, but I'm making my own shadows here, which isn't helping for the camera, but I got jackpot. I knew the problem had to be in this section between here and here, so I started tearing back a little bit, and I want to show you guys best I can once I find it. I saw it for a second and I lost it. Alright, that, my friends, is what we call in the field a green wire. Right there. So that's our circuit that's got a voltage drop. At least I'm pretty confident it is. I mean, it's definitely green. And you remember that 11 something volt drop we had before? I put my piercing probes on here so we can take a look and see what the voltage is. We're dropping 11.13 volts across that circuit. So we're going to fix that up, and then we'll test the voltage at our mass airflow sensor. Also, a note to anybody, when you get in a situation like this, always check around for other wires that may have damage, because there might be something else that was rubbing, causing another circuit to go bad in the very near future. So I'm going to inspect this. Alright, we've got our cheap dirty fix in here for temporary. This is not a proper repair. The best way to do this would be to solder and heat shrink these wires, but this is just a temporary bypass so we can see what's going to go on here. Check our voltage to the mass airflow sensor. I'll turn the key on. Oh, turn the key off. Somebody forgot something. What did they forget? Brian forgot to plug in the computer. I knew I was forgetting something. I had to get that up and out of the way so I could do it. Always make sure your key is off when you plug and unplug computers, guys. You will cause all kinds of problems if you have the key on. Chances are nothing will take a dump on you, but it's always key off at minimum. I've got guys that swear you got to have the battery disconnected, but to each your own. Alright, now let's turn this key on. Take our meter, we're gonna ground our meter. Always test your meter, guys. Ain't no point of checking stuff if it's not reading right. So I'm testing for battery voltage, we're good. And I'm on back probe. And we got battery voltage. So I'm gonna go ahead and button up part of this just to get the car running, and we'll see what happens. Alright, so we're gonna check our codes again. probably set a boatload of them by having stuff disconnected and testing around. Come on, I'll tell you, you can do it. Let's see, current and history. And we do have a lost communication with the TCM, but that's because I cycled the key really quick with the computer missing, I think. Not 100% sure about that, but we'll figure it out. So let's erase all the codes. And once this is done erasing, we'll fire it up and we'll go see if we have a mass airflow sensor that is reading. Okay, codes are erased. Excellent. So I'm going to go fire this puppy up. Okay, so I've apparently got something else disconnected somewhere. So now we got no communication with the TCM. I did not unplug the TCM. It's way down there. Get the light on here somehow so you can see the TCM's right down there. Not coming out too well. But we were in this harness right here picking around. This is the TCM harness. I just unplugged it because I wanted to get a visual on this, make sure we don't have any green stuff growing. And there are some possible nicks. I'm going to take a look around here and see what we find. Took the cover off so we can get in there and back probe and test. I'm on the TCM black and white wire going to ground. I have 1155. That's a bad ground if I'm on the right wire. So let's find that out. Turn off my headlight here. So I'm looking for a diagram for the TCM. We can just go to diagrams, or actually motor wiring diagrams, I'm sorry. Transmission control module, motor wiring diagrams. So we start up top with our powers coming in and cruise down here. The black and white wire, which was the big one, terminal 49, should be a ground. That goes to G107. As this vehicle had a higher than normal ground when I was just testing it originally, I think we probably disrupted that ground doing the repairs. So opened up a can of worms. That's the way it goes working on cars sometimes, but we'll fix it. And I'm just doing a look for where G107 is. Just click on this, and we're gonna scroll down to G107. See if they do it like that. No. G107, and this is an LZ4. And G107. I messed up and didn't get the chance to record the end of this video the way I wanted. The ground 107 had high resistance, was all corroded, and I missed that. But you can see here, as I'm wiggling the ground, you can see the voltage. This is the back probing the TCM. It's going high and low. Guys, thanks a lot for taking the time to watch. If you guys like this type of stuff, let me know. I'll keep it coming. Have a great day, everyone.